Welcome to week 4, day 4. Today we're going to be working in chapter 1, section 4, but you'll notice it says day 1 because we're going to be finishing this up on our next lesson. We're going to be looking at angle types and angle addition postulate. So 1.4, measure and classify angles is the name of our section, day 1. To name and classify angles, to apply the angle addition postulate. So before we get started, let's talk about what actually makes an angle. An angle, by definition, is the shape formed by the intersection of two rays. So you'll notice right here I have two rays. They are intersecting at a point. So in an angle, the rays are called sides. So each ray is a side, and where the two sides intersect, that point is called a vertex. Between the two sides, this area all in here, and remember it would continue to expand out here because the rays would continue to expand. All of this in here is called the interior of the angle, while everything out here, outside the two sides, is called the exterior. So how do you go about naming an angle? We know from previous lessons that we have symbols for segments, and rays and lines and planes, and so now we have a symbol for angle. It pretty much looks like the angle shape, but we're going to put a little arc in it. So the angle symbol looks like this. Now, if you choose not to put that little red arc into the symbol, that's fine as well. So here it is. Here is the angle symbol. The vertex of this angle is A, so the easiest way to name this angle is call it angle A. Now, you don't have to put the arc in there if you don't want. You can just make it look like an angle. But what about these other 2 points? Well, these other 2 points can also be used to name the angle. The important part is that the vertex is always in the center of the name. So we can start at B, go down to A, pivot around to C. So that would make it angle BAC. Now you'll notice there's an or there. That is because these are the same name, these are different names for the same angle. But what if I didn't want to start at B? What if I wanted to start at C? Then it would be angle C to A, pivot around to B. So angle CAB. All 3 of these are naming the same angle, so it doesn't matter which one you use. So one angle, but 3 names. But what if there's more than one angle in the picture, which is generally the case? So something in this range. So that makes 3 angles in this picture. There's an upper angle, a lower angle, and then the original overall angle that we had previously. So there are 3 angles. So previously, because there was just one angle, I could call this angle A. So you'll notice my angle A is down here at the bottom. It's not one of my 3. And that is because all 3 angles are using the same vertex. So if you say angle A, I'm going to ask, well, which one? So angle A, the vertex only, is not allowed. So no vertex only if you're looking at a multiple angle picture. So let's start with the one we already know. We already know angle BAC. Now we also know that it could be in the other direction, angle CAB. So let's talk about this upper angle here. So it starts at B, goes down to A, and pivots around to D. Or it starts at D, pivots around to A, and becomes B. So angle BAD or angle DAB. So why is this 1 here? Because if there are numbers inside, they're not a value, they're not a degree, they are a name. So you could actually also call this angle 1. So then the bottom, we can start with the points, angle DAC, or go back in the other direction, angle CAD, yep, or we can call it angle 2. Okay, so question, Are you taking notes at this point? If not, please pause the video and get out a sheet of paper. You should be taking notes. Either print off the fill in the blank form or do it on your own sheet of paper. Hey, welcome back. So now we're going to look at classifying or typing or identifying. This is not naming. The difference between naming is you're using letters, like your name has specific letters. These are classifying as in just determining the type. So girls are in general, then each girl has a specific name. Boys are in general, and then each boy has a specific name. So it's also kind of like dogs. Dogs is a very general statement, but then each breed has its own name. So we're just going to classify these, kind of like the working dog, the royal dog. I think that's made up. I just remember the working dog one. Okay, so these are probably ones you already know from previous math classes. This first angle is an acute angle. And how do I know that? Because this angle has a measure somewhere less than 90 degrees. Now currently I don't know the exact measure, but I definitely know it's less than 90, so it's acute. So that's why it's a general classification, because there's all kinds of angles less than 90 degrees. And this angle is greater than 90 degrees, so it's obtuse. So anytime you have any angle greater than 90 degrees, it's obtuse. Okay. Then we get to this one, and most of you are going, oh, that one's right, that one's right. Well, now you're in geometry, and I don't know what previous classes have told you, but in this class, remember, we can't say something unless we know it for certain. And because a right angle is an exact measure, remember, this is a range of measures, anything greater than 90. Since this one's an exact measure, you can't say it's right unless there's a little box in the corner so that you know for a fact it's exactly 90 degrees. We do know that collinear means a straight line, but this is not a collinear angle. This is called a straight angle. And because it's a straight line, a straight angle, we know it's exactly 180 degrees. Okay, so let's do some examples. First off, let's classify angle BEA. So it's kind of like saying what class of dogs is a beagle. We know a beagle is specific. So what kind of angle is angle BEA? Well, there's a right angle box, so it's a right angle. Name an acute angle. Well, how many acute angles are there in this picture? That's right, there's two. Because if angle BEA is right, then both of these angles in here are less than 90. So you get to choose. You can either take the upper one, angle BEC. Now what if you said angle CEB? Were you right? Correct, you were. Or the lower one, which, oh, sorry, that was the discussion we just had. I apologize. So these are both the upper ones, so either one of those will work, but then there's a lower one, angle CEA, and then of course the other direction. So basically when it says name an acute angle, there are two of them. Angle BEC, or however you arrange the B and the C, and angle CEA, or however you arrange the A and the C. So it just says name one, so it doesn't matter which one of those. So then number 3 says name a side of angle CEA. Remember, the sides are the rays. So angle CEA is this lower one, and the rays are starting at the vertex. So no matter which one you pick, you start with E. So ray, well, that is wrong. Sorry about that. Let's fix that. Okay. Angle CEA would be ray EC, or what's the other ray? Yep, you're right. It's ray EA. Sorry about the handwriting, considering I'm using a mouse. Okay, that was a typo. I apologize about that. Okay, so our first objective was to classify and name. That's what we've done. We've classified them as acute, obtuse, right, or straight, and we can name them by using the points, making sure that the vertex is always the center point named in the angle. So now we're going to do the second objective, which is to apply the angle addition postulate. Now the angle addition postulate is like the segment addition postulate in that you will be dealing with measures, and so we don't know the symbol for that yet, so let's talk about that. We already know the symbol for angle BAC. It looks like the angle. Now this time I wrote it without the little arc to show you what that looks like, so you can put the little arc or not. So angle BAC, that's the actual physical item, just like segment BC was a physical item. Meaning, so this is kind of like a boomerang. Like I can pick up a boomerang and I can play with the boomerang. So this is the physical item. But if I want to talk about the measure of the angle, it's open 120 degrees, then that's a different symbol. Now in the case of a segment, we removed the stick to go ahead and talk about a measure. Segments are the only one where we remove something from the notation to mean measure. Everything else, we're going to add to the symbol to mean measure. So we're going to add a little m. So the measure of angle BAC. This is the number in degrees. So 90 degrees, 60 degrees, 37 degrees. And that's how we're going to know that we're talking about a number. Okay, so the angle addition postulate works like the segment addition postulate, except we're going to talk about angles. So it's still a sum. The sum of the measure of two adjacent angles, remember adjacent means right next to each other, is equal to the total measure of the overall angle. I know that is kind of redundant, but I wanted to make a point of that. Okay, so you're going to have a picture that looks like this, where we have two angles. And reality, I'm really kind of limiting this by saying the measure of two adjacent angles. It could be 3 or 4. It doesn't really matter as long as they are adjacent and they're fanning out and making a bigger angle. So we could have 3 angles that are adjacent as long as they're fanning out to make one big angle. So I'm just going to start at the top. You could start anywhere you want, but I'm going to start at the top. Remember that the two smaller angles will add up to the biggest angle. So my upper angle is angle BAD, so the measure of angle BAD plus, because it's a sum, the measure of the lower angle, DAC, equals the measure of angle BAC, because these two together fanned out to make angle BAC. So the question has come up, and it came up during segment addition postulate. Do you have to do it in the order that you're showing us? Not really. The important part is that you understand that the overall angle is by itself. So another example of what this may look like is, let's say I started with the overall angle first. So the measure of angle BAC equals, and then since I was down here at the bottom, I just started there. The measure of angle CAD plus the measure of angle DAB. So the important part is the two smaller angles add together, and that's equal to the overall big angle they fanned out to. Just like the segment addition postulate, we're always going to start with the geometry first. So we're going to start with this equation, this blue or red equation. Remember that red means you don't have to write that in your notes. It's just something extra if you want to write it in there. So feel free to go ahead and pause the video so you can go ahead and get caught up. So this is an example 0. You'll notice it says example 0, which means that if you are using the fill in the blank notes, they are not, this example is not there, and you don't have to write it down, just simply watch. So we are given that the measure of angle X, Y, Z is 72 degrees. So X, Y, Z. So this overall fan is open 72 degrees. We're going to find the measure of angle XYW. Now, when we did this in the previous sections, it tended to say find X and then find the length of the segment. This section does not tend to do that. They just say find the measure of this missing angle. Well, if you look at angle XYW, it has an X in it, an unknown value. Well, if you don't figure that out, you can't move on. So we're going to do the angle addition postulate. No numbers yet. So I'm just going to start up here. Apparently I started down here, down at the bottom. Angle ZYW plus the measure of angle WYX equals the entire fanned out angle ZYX. Now, if you did not like that order, let's say you started doing this before I did and you went from the top down, this was the same equation from the top down. So start there, XYW. Okay, so just like the segment addition postulate, we write the geometry and then we substitute. You'll notice that there are parentheses here, just so that they can put the degree symbol on there. Those parentheses are not really necessary. So you can just write 2x minus 9 plus 3x plus 6 equals 72. Then just like week 1, we're going to do our algebra, combine like terms. So 2x plus 3x is 5x, negative 9 plus 6 is negative 3. So 5x minus 3 equals 72. We're going to isolate the x by adding 3 to both sides. So 5x equals 75. And then we're going to solve for x by dividing by 5 on the left and 5 on the right. So x is 15. Okay, so remember, we're not done. It said that they want you to go back and find the measure of angle XYW. So you are required to write that down. The measure of angle XYW equals 3x plus 6. Because when you do your work in math, you are having a true conversation with somebody. So we don't want to leave out any sentences. So this is what we're going to substitute into. And we're going to substitute 15. And then we're going to do order of operations. So 3 times 15 is 45, plus 6. Keep bringing down the plus 6. So the measure of angle XYW equals 51 degrees, because angles are always degrees. Okay, so this is, we're going to go back to your notes. So given the measure of angle EFG is 93 degrees, find the measure of angle EFH. So you don't have to do this to your picture, but you may want to. This overall angle is being given as 93 degrees. And then we're going to start with the geometry. So either start at the top or start at the bottom. Honestly, I tend to start from the top. I don't know why I did the example 0 from the bottom. So angle EFH, the measure of angle EFH, plus the measure of angle HFG equals the fanned out angle, angle EFG. So go ahead and pause the video, because I know sometimes it takes a while to get that written down. So now we're going to substitute. So the measure of angle EFH is 2x plus 2 plus, because it's the angle addition postulate, the measure of angle HFG is x plus 1 equals 93. Combine like terms. So 3x plus 3 equals 90. subtract 3 from the left side and the right side because you're going to isolate the variable. So that's 3x equals 90. Divide by 3, so x is 30. We're almost done. Not quite. Which angle are they looking for? They're looking for the measure of angle EFH, so we write that down so we can tell whoever's reading our work that we know what we're looking for. We're going to substitute in 30, so 2 times 30 plus 2. Order of operations says multiply, so 60 plus 2. And so the measure of angle EFH equals 62 degrees. You can always double check that, because if x is really supposed to be 30, then wouldn't this lower angle be 31? If the bottom one's 31 and we just said the top one was 62, is that the 93 it's supposed to be? Yeah, so you can always double check your work. Okay, so I'm going to go on to the next example, so if you need to pause, please do so. So this is our last example. It says, given the measure of angle POR is 61 degrees, find the measure of angle QOR. Now you'll notice this picture is kind of weird because there's that little arc mark, and you're like, but wait, didn't they say the whole thing was 61? They did, but because this one is so thin, the measure can't actually get placed in there. So this is really an arrow indicating that's the angle. So if you're going to put the 61 in there, the 61 is all of this. And again, this isn't required, but if you want to, go right ahead. Okay. So we're going to start with the geometry, the measure of angle POQ, measure of angle POQ, plus the measure of angle QOR, because remember the vertex should always be the center letter, equals the measure of angle POR. So now we're going to substitute. So the measure of angle POQ is 3x plus 7 plus the measure of angle QOR is 5x minus 2 equals 61. Now I really would prefer that you pause the video at this point and go ahead and try it yourself to see if you can get the final answer and then come back. Okay, so we're going to combine like terms. So 3x plus 5x is 8x. 8x plus 5 equals 61. And then we're going to subtract 5 from both sides because we're isolating the 8x. So 8x equals 56. Divide by 8, and x is 7. Almost there. The measure of angle QOR is what we're looking for. So we're looking for 5x minus 2. So 5 times 7 minus 2. Order of operations gives us 35 minus 2. So the measure of angle QOR is 33 degrees. Again, please go back and rewatch this as much as you want. Please take notes. It's very important that you take the notes, that you're doing the assignments on a separate sheet of paper, that you are in fact doing the work as recommended, because when we come back to in-person teaching on campus, I will expect you to have good work ethic at that point, so please don't be cheating yourself out of that good work ethic. Please also make sure you're paying attention to the questions on the form. The form may ask you to stop at X, or it may ask you to go on. So please make sure you look at that. If you have any questions, email your instructor, your teacher, ask for a Zoom meeting, and don't forget we're taking, oh, sorry, we took the test yesterday. So I hope you took the test. This is the second half of Chapter 1.